so we can see the screen sharing. Okay, yeah. Good evening, everyone. Great to see so many people here. It's like, as Henrik said, it's been a lot of weather today, so good that you could all join and come here and listen to us. So today, I wanted to talk about how to achieve DDoS resiliency in web applications and what you should think about when you build this kind of solution. I will go over like the overall building blocks for important stuff when it comes to protecting your infrastructure, what you should think about, like trying to keep things a bit simplistic here, not going into much detail. As Henrik mentioned, my name is Johan Aldor. I'm a solutions engineer here at Akamai. So I help out with the technical stuff during the sales process. I will try to avoid making this too Akamai focused and more of a generalist idea on it, but it will probably be quite Akamai influenced, right? So with that said, I wanted to dive in and start with asking you to join in on a Menti with me if you have the possibility to answer some questions or actually think about like important stuff around the DDoS protection. So I'm going to jump over here and do like that. So here we have the code. And when you join in here, you get the possibility to basically fill out some question and give some time for people to join. So the question is basically around what would you say are, I'm going to add the join code down here left of if you want. So the question I wanted to ask basically is when you think about your web application, what are like the three crucial components that you have? What needs to be working for people to be able to reach your web application? Definitely onto something here, let's say. And yeah, feel free to fill in here. And what I will do is that I will return to this screen in a little while. First, I have some statistics to present from Akamai on what type of attacks we are seeing and what we are facing in the Nordics and EMEA, basically. Let's switch to this. Yes, we talked about that. So why are we talking about DDoS protection and that kind of stuff? Because we have had like kind of a rough year when it comes to DDoS in at least Sweden and the Nordics. There has been a lot of different attacks from different types of actors on different kind of actors in the world. We have seen attacks from different state actors. We have seen individual organizations and different attack groups making attacks on a lot of different companies, municipalities, kommuner, and many different companies in Sweden. And if we take the Akamai view on this, I prepared some statistics from our layer 3 and layer 4 protection. So this is basically what we're seeing now is the DDoS events per month in the EMEA region for Akamai. And this is where we protect our customers from volumetric DDoS attacks. So things like UDP floods, ICMP, NTP attacks, and similar stuff, protecting data centers from DDoS attacks. And if you count this, we see that basically on an average, if we are excluding February, we have had like 170 DDoS events per month on average during the last 12 months, meaning that we protect our customers from like 5 to 6 attacks per day. So that's quite a lot. And these are events that have been triggered when our SOC is actually manually intervening with attack. This does not count any like proactive measurements, and then we have been able to build proactive mitigations. So the threat is definitely out there, and we are seeing lots of different attacks. So this was for the layer 3 and 4 attacks. If we look at the layer 7 attacks, so this is basically the next layer of attacks that you would see if they don't succeed on the layer 3 and 4. So when they attack the application on layer 7, they look at things like search forms, logins, and similar. And these are the amount of requests per day that we see in different verticals. So what I've done is I've taken this diagram and added stacked the lines basically. And as you can see, we have around 3 to 4 billion attacks per day, basically, counting requests per day, counting as attack traffic, and the trend is going steady up. Looking at Scandinavia, there is a little bit less traffic, of course, but still quite a lot. We have had a big attack in beginning of February and of January here. Trend is a bit more stable, although the graphs is a bit skewed because of the last big attack, but it's going a little bit upwards in Scandinavia also. And of course, this gives you can see it in media, as should before, but we also have different attacks. For example, we had an attack attacks during Black Week and Black Friday last year. Was one big provider, Power, they went down because there's an attack, and we could see, and for that they could see probably a clear business impact. Actually, we also have other customers on another customer on the platform, Elköp, which is a competitor of Power, of course, and they were also facing similar attacks. And the thing is that when we look at that attack, it was performed from like 80 different countries or so. It had over 700 different ASN numbers involved and over 3,000 different IP addresses, and they were also mixing up user agents, meaning that the attacks are very distributed and very large in nature, and it's very hard to protect with like standard and like how we use protection with all the encryption firewalls and stuff. So quite a big hit, and for Power to go down on Black Friday, for example, would be a extremely big hit because it's a very important day for e-commerce companies. I also just, now it's hard to see here, but I also just Googled last week and found out that APG, a Swedish company, had a big DDoS attack also. So it's very common, and we need to really have this in our strategy when we think about protection. What's good to know, basically, is that protection from these attacks requires you to think a little bit different, I would say, compared to if you look at the attack. It will always be that your infrastructure will always be smaller than the attacker's infrastructure. Because what the attackers are doing, they're using the internet, of course, which means that they have very large capacity, they have very many devices to use, and it's very hard to protect from that if you are running on a single location, which probably is the case because you have your applications and so in a single location. So that's why we need to think distributed when it comes to protecting from these kind of attacks. So I'm going to return to the question, and we can check the cloud here real quickly. Works. And we have a few things here that's important and that I will touch upon them. I see network here, it's very good. We have the front and back end database that will be, or application basically would be also one of the points I would take up. But I don't see DNS, for example. So yeah, let's have a look what we at Akamai see as like the most important building objects for your DDoS protection. So basically, let's go very much back to basics here. The most important building components that we think you should focus on. First one being your authoritative DNS right. It's a very easy way of attacking a company to take down their DNS. And we know that when your DNS goes down, it will bring big problems because your data center, your application, or whatever, it could be functioning very well. But if your DNS is not making the translations to IP addresses for you, people will not be able to reach that, right? So it's a very important thing to keep in mind when you think about your DDoS strategy. The next one is, of course, connection, network. We need to be able to be connected to the internet, right? We need to have some kind of protection on our ISP connections that we can provide the data to our end users. And then we have your application. And this is where you need to have some kind of specific application protection around your website. So you avoid running out of CPU power or connections or whatever, basically, to your application, so that will be able to hold through. And I'm going to start with talk about DNS. And as mentioned, DNS, it's everywhere. We need it for everything. We unfortunately don't see it as a necessary sometimes, or we see it as a necessary, of course, but it's often missed out on. We don't see it as vulnerable that often. We don't often treat it as a priority. It's something we set and we let it run and we basically forget about it and so on. And we don't always make a well-made implementation with redundancy and and stuff. And if you get any issues with your DNS, that would of course create major problems for your organization. It might not only be the application; it might be a lot of different stuff that goes down, so to say. So it's important to remember DNS, and just to make sure that everyone is on the same page. At DNS, when someone goes to your web page or sort of session on your website, it always begins with that DNS lookup. So don't forget about this. Otherwise, they won't be able to get that to that site. It's important to them. And also make sure to think about the response times if you want to have a fast web. So how do we suggest that we build our DNS? Well, DNS is not to say easy to build reliable, but it has a lot of mechanisms built in that it will make it easy to build it reliable. We have a primary secondary setup, so you can synchronize your zones. There is built-in caching for recursive resolvers, and many different things that would basically allow you to build a distributed setup. So we would like to see a distributed DNS setup where you basically build it into different availability clouds. Make sure that you have it distributed around the world so that you have responses close to end users. You have high capacity to be able to absorb attacks, because the DNS attacks are a bit different. They are very packet intensive. You would not see high volume DNS attacks because that would be hard to generate that kind of volume. But in terms of requests per second, it can be very high. And if you build a very scalable and distributed infrastructure with basically different availability clouds around the world, you could map users using Anycast or something like that. You could get really good uptime possibilities. And there are many providers today that runs these kinds of services that you can basically talk to. You should also look for something like an SLA for your these set of services so that you don't need to worry about it basically, because DNS is something that should just work and should always work. The third one is that we need to have some kind of internet connectivity, right? And this is where we talk about the volumetric DDoS protection. So volumetric DDoS protection is very important, because this is where you get your internet pipes filled up with data or your equipment being overused. The attack landscape is often that we are seeing different types of attack vectors, such as LTP attack, UDP attacks, different types of TCP attacks, and so on. And your infrastructure needs to be able to handle a lot of different attack capacity. Typically, we can have something like a network edge that looks like this, very much in a simplistic way. We could place our DDoS protection somewhere here, perhaps, around your own equipment, if you buy some boxes or stuff. Or you could place it here and acquire it from your ISP. However, there are, of course, challenges with this because it doesn't really scale, because you have an issue with the actual network capacity. Definitely, if you run it on your own borders or in your own data center, there might not be enough bandwidth to basically handle an attack. And how should you be able to mitigate from that then, if you cannot even block it enough far away from your network? ISPs might have the same issues with very large attacks, and so on. And it might not only be network capacity; it could also be packets per second capacity. Your routers might not be able to handle, or firewalls might not be able to handle the amount of packets per second they send. Another challenge with this is that you typically buy 1 or 2 boxes, and the same goes for your ISP probably. And typically these boxes, they are good to protect against 1 or 2 vectors, meaning that if you get what we often see today, 10 different vectors when it comes to attacks, you are not able to get efficient protection. Then it's also about the experience. If you receive such an attack, how often does it happen? It's not like you get an attack every week or something like that, so you don't really get the experience on how you would protect yourself from these kind of attacks. So building an experienced team is also very, very hard around this. And probably also, if you have something with your ISP, have you looked at if they have any kind of protection SLAs? Are they able to actually Yeah, okay.
Sorry, could you explain just the point there on protect against one or two vectors?
Yeah.
You said you're seeing 10 attack vectors. What do you mean by attack vector?
Yeah, so different attack vectors could be like different types of attacks. So if it's a simple UDP fluid could be one attack vector, NTP fluids could be another attack vector, and then you might have TCP SYN attacks. You might have so basically different types of attacks. And often these devices, they are good at one of these attacks or two of these attacks, basically. Yeah. So I wanted to show this again. Think about the whale as the internet and the small whale as your internet connection, basically. It will be absorbed. It's just how it is when you perceive a large attack. So what do we do then? Well, let's use what attackers are using. Let's use the internet to build protection and build protection close to the attacking devices instead. So instead of putting your protection close here to your border, put it close to the edge of the internet, close to the end users where the devices are, and then backhaul the clean traffic over the internet to your data center. And you could also, for example, connect a SOC to this. This gives a few different benefits. Of course, it scales because we have the capacity of the internet. We can build this in countries, we can build this even in cities, and thus we will be able to absorb a lot more traffic on these points, basically. So mitigate attacks close to the source. We could also use a standardized set of appliances in these scrubbing centers. So instead of having, if you have multiple data centers, you might be having multiple boxes for protection. But if you're running the scrubbing centers, you could have a standardized set of appliances and also a few different appliances for protecting against different vectors. And that will give you standard protection for DCs, of course. And also have a SOC that is dedicated to protecting against DDoS, an experienced SOC team that is working on protecting against multiple attacks every day or every month, that you have, when the attacks hit, you have someone that understands the vectors and how to mitigate from them, what appliance to use, and so on. Perhaps you should also implement proactive mitigations. So while you typically would run your firewalls down here or something, you set allow open ports or whatever you do, basically. And that could block then unwanted traffic. Set those policies out here instead at the scrubbing center level, close to the end users and the attacks, meaning you don't get unnecessary traffic to your data centers. So building distributed is basically the key to get good protection for your data center. The next thing that you need protection from is your application, and this is where things get a little bit trickier. It's a lot of different things to take into consideration. Every application varies a lot. Networks might be a bit similar to each other, but applications vary a lot. And if we talk about web application more specifically, there is a lot of different types of attacks here. If we talk about DDoS attacks, we're talking mostly about rate attacks, where we overload the application with requests, or bots performing different types of overloading. And the consequences could, of course, be that the application goes down or gets overloaded or slow, so that end users can't really use it. And to protect against that, we typically would use something like a web application firewall. And that would, of course, have layer 7 rate controls and bot protection to control basically the amount of requests per second that is possible to make to your web application. Before going into like the architecture of how you should set up your application firewalls, I wanted to mention some like highlight capabilities that I think you should have and be aware of. And starting with caching is actually one of the more important features for DDoS protection. So try to cache content close to your end users also, because that will also give you protection from DDoS attacks. Cached content can be requested how much ever the attacker wants. It won't have an impact because if you have many deployed reverse proxies deployed, you have very high capacity to serve cached content. But remember to consider the cache key when you do this, because attackers, they usually change the cache key, so they want to go forward to the origin server to find new objects and overload the origin server. The other one is, of course, rate controls. Make sure that you have a web application firewall that supports rate controls and being able to configure the rate controls on different conditions, such as being able to set the window for how long you should look at your bursts of requests or your average amount of requests per second that you allow to specific endpoints. Being able to control what user agent, geographical areas, or IP addresses, or even TLS fingerprints that you would control. So having a very good and customizable rate control is important. Also to couple this with some kind of reputation information. So to clear out the noise, having high risk IP addresses communicating with your infrastructure might not be what you want. So make sure to have some kind of IP reputation threat intelligence built into this platform also. And lastly, we have the bot traffic visualization and mitigation, because what happens when the bot or the attackers finds your thresholds for your rate controls? Well, they go just below the threshold. If you have a threshold of 10 requests per second, they would definitely come in around at 9.5 requests per second or something like that. And this is where you need good bot traffic visualization and mitigation possibilities, where you can categorize the attacker's tools into something instead, so that you can basically set constraints on the tool used and not the request per second. So how do we typically run a web application firewall? Well, we place it close to our web service for some reason, on the wrong side of the internet, which of course gives us challenges because it does not scale if you have a single one close to your web service. There might be a challenge with experience on protecting from attack. You might not know how to set up your rate controls and tune them correctly. So it's important to have a good team that has experience with protecting from these kinds of attacks. Protections get too close to the data center. Same here. Your equipment might fail. HTTP is also quite a high intense request-based protocol, so things might fail there. And of course, if you run on many locations, there would be a lot of different web application firewalls to manage and control, right? So what do we suggest instead? Well, let's do the same thing as we did with the volumetric protection. Let's run that on the edge of the internet, close to the source of the attacks and your end users. And then we backhaul clean traffic to the web service when it has been verified with the firewall. And of course, with this kind of service, you can also get a single pane of glass view for all your web services. This doesn't have to be a single web service, it can be multiple web services that runs behind this. So benefits, of course, it scales. You run on the internet, it's distributed, it has basically unlimited scale and can handle a lot of traffic. It also gives you some built-in layer 3 and 4 protection, actually, also. And this is because these web application firewalls, they will only forward correctly formatted HTTP traffic to your origin server. So if you get any NTP traffic or ICMP or something like that, the web application firewall can just drop that because we only want HTTP traffic to our origin service or our web service. I used to say that we all can block UDP also, but now HTTP3 supports UDP, so I can't say that anymore. But the concepts apply, right? So yeah, block unwanted traffic to get some kind of layer 3. If you run this combined with a CDN, for example, you can get a very large cache footprint. You can cache out your CSS, JavaScript, even APIs, whatnot. And that can be requested many times and won't be an attack vector then. It blocks attack far away from your data center, so no problem with your connection to the internet being clogged for that reason. One single place to manage all web application firewall. And possibly you could look for a supplier with a managed service and a basically uptime SLA for these type of services also. So I'm coming to my conclusions here. This was kind of an overview of the protection. I have not really got into any details of how the protection can actually be made. But what I want you to get out from here today is that you should run your protections distributed. You should not run them in your data center with these kinds of attacks. And if you run them distributed, you would be able to manage the load of a large DDoS attack. So, not sure if you have seen this before, but basically heat, oxygen, and fuel gives you one thing, and that's fire. In the same way, these three would give you a working infrastructure if you think about that. So authoritative DNS, connectivity, application protection. So yeah, keep that in mind. Back to basics. And that's what I want to present today.